Section 1.5 in college algebra is about composition of functions. So, in the first few examples, they give you function f, which is 3x plus 1, and function g, which is 2x squared minus 5. We're going to evaluate some operations of functions and then also give domains. So, let's start with f plus g. If I were to add 3x plus 1 and add it to 2x squared minus, that's a squared, minus 5, and I combine my like terms, I get 2x squared, and then plus a 3x, and then negative 5 plus 1 is a minus 4. Now since that is a polynomial, or quadratic in that case, the domain has no restrictions, so our domain is negative infinity to infinity. When I do f minus g, start with 3x plus 1 again, but when I subtract g, I need to make sure that I subtract the entire function, in other words, distribute the subtraction sign. So that will give me a negative 2x squared, and then still a positive 3x, but then here the 1 minus negative 5 will become a plus 6. That is still a polynomial, it's still a quadratic, so the domain is still negative infinity to infinity because there's no restrictions. F times g, we're going to take this binomial, and notice I'm putting them both in parentheses, and we're going to multiply it by this binomial, also known as a foiling problem. So 3x times 2x squared is a 6x to the third, and you can FOIL this in whatever order you want. I like to do this in standard form order. So I'm going to put a plus 2x squared and a minus 15x. Any order is fine though, like I said. We have another polynomial, no more like terms to combine, and the domain, because it's a polynomial, it's a cubic this time, is still a negative infinity to infinity. Now when I do function f divided by function g, the setup is really easy. However, there are issues for our domain. Remember, the two things we need to worry about is if we have a square root or a fourth root, which we do not. And the other issue is we can't have a 0 in our denominator. So we need to think about what would create that situation. 2x squared minus 5 cannot equal 0. So if I solved for x, let's see, I'd add the 5 and divide by 2. And then when I square root both sides, this results in two answers that would give me problems. If it was a positive square root of 5 halves or a negative square root of 5 halves. So for your domain, what I want you to write down is just simply that x cannot equal positive or negative square root of 5 halves. So this is your function, and this is the domain. That is hard to read, sorry. Now, composition of functions is putting one function inside of another, and it does help if you use colors. So I'm going to call the f the blue function and the g the red function. So when they say put a g inside of f of g of x, what you do is you start with f, but where the x is located, you're going to leave a big empty space. So instead of 3x plus 1, it's 3 and then blank plus 1. Inside of that input position, we're going to put g, which is 2x squared minus 5. And then of course we're going to need to simplify that. So that gives me 6x squared minus 15. There's still a plus 1 off to the side. When I simplify that all the way, I get 6x squared minus 14. And I think they still want us to give domain, so since it's a polynomial, the domain is still negative infinity to infinity. Excuse me. G of f. And that's a different notation, but it can be written the same way. You could rewrite it as g of f of x. So this time we're going to start with the red function, which is 2 times, instead of x squared, we're going to write blank squared minus 5. And then in place of the input, we're putting the other function, which is 3x plus 1. Now this one is far more complicated. The 2 coefficient is going to stay, but when I square a 3x plus 1 times a 3x plus 1, it's really a FOIL problem. So I'm going to keep the 2 in front and FOIL that out, so we get 9x squared, 3x and 3x is plus 6x plus 1, still minus 5, and then, almost done. Distribute the 2. And then still not done because now we have some like terms right here we need to combine. So 18x squared plus 12x minus 3. So that is my final answer. The domain, again, because it's a polynomial, is negative infinity to infinity. Same functions, except this time we're going to be evaluating these functions through composition but with numbers. So what they're telling you is evaluate f of g of 2. And when they give you a number, you could also write it like this. You actually have to start on the inside. So you're going to start by finding g of 2. So let's do that. G of 2 would be, oh, let's see, 483. And then you're going to take that number, 3, and put it in place of the g of 2, because that's what it is. So now what we're evaluating is f of 3. So when it's composition with numbers instead of variables, you are going to compose from the inside out. So the final answer to that question is the number 10. You're not going to give domain on these because you're evaluating and not simplifying. So g of f of negative 3, we're going to start on the inside and find f of negative 3. So 3 times negative 3 plus 1 is negative 8. And then I'm going to take that number and put it into the next function, which is g. So using parentheses, oh, let's see here, that's 64, 123. And of course, check it on a calculator because I'm sure I made a mistake. And then, number 9, it's 3 times f of 2. So we're going to calculate f of 2, and then we're going to multiply it by a 3. So f of 2 would be 3 times 2 plus 1, which is 7. So 7 times 3 is 21. And then on number 10, I can't read it too well, but I think it says 4 times f of 1. So f of 1 would be 4. So 4 times 4 is 16. Times, and then it says 2 times g of 6. So g of 6, it's going to take a little more thinking. 36, 72, minus 5 is 1. Nope, I did something wrong. Oh, times 2 is 134. So 16 times 134 is 2,144. Whew. All right, more composition. New functions. We've got, there's f of x, and here is g of x. And if I do f of g, which means put g inside of f, you start with f, which is the square root of x, but I'm going to remove the x and replace it with the g function. Now there's no simplification that can happen there. However, there is definitely a domain issue. We have a square root, and I know that what's underneath the square root has to be greater than or equal to 0. So for me, whoops, that means x must be greater than or equal to 4. So his domain is 4, and then everything bigger. Bracket on 4, because 4 is acceptable. We can take the square root of 0. When I go the other direction in g of f, instead of x minus 4, I'm going to put blank minus 4, because in place of the x, I'm supposed to put the other function, which is square root of x. So my function is just simply square root of x minus 4. I do have a domain issue. What's underneath the radical, which is just plain old x, has to be greater than or equal to 0. So my domain is 0 and everything bigger. The negative 4 doesn't affect the domain at all. It just shuffles the function down 4 units, but that doesn't affect domain. Okay, number 13. Big ol' mess. F of g. So start with f, which is this guy. So instead of x plus 2, we're going to put the 1 over x in place of the x. So if I kind of simplified this, I'd be 1 over x and then plus 2 off to the side. Domain issue is that your denominator cannot equal 0, so we're just going to say the x, which is the denominator, cannot be 0, and that's the only problem we're going to run into. Now for g of f, it's 1 divided by, and then instead of x, we're replacing that with the other function. So that is the function, but I know for my domain issue, my denominator cannot equal 0, so that means my x cannot equal negative 2. Everything else is fine, just not that. I'm okay if you put these sort of domain issues in informal notation as opposed to interval. The intervals are kind of annoying on those. All right, composition, this time with graphs. So we're going to start on the inside and find g of 1. Now notice they labeled the graphs. One's f and one's g. Oh, excuse me. So when I find g of 1, I go over to 1, and then I have to find where the function is. Now there's a hole down here, so that's not the point I'm interested in. That is the output right there. So he's an output of 0. So this is really f of 0. So now I go to my f. Here's 0, follow him to the function, and he gives an output of -1. And that is my final answer. And this function, because we're doing evaluation at numbers, you start on the inside. So f of 3, if I find the function, he's right up there, output of 1. So what this really says is find f of 1. So here's 1. There's your function output. Again, the answer is -1. And then here it's 2 times f of -1 over 4 times g of 2. So 2 times f of -1. -1 gives an output of -1. And then for g of 2 gives an output of 1. So we end up with -2 over 4, which of course I'm going to ask you to reduce to a -1/2. And that is composition of functions. I know you saw quite a bit of that back in Algebra 2, but just picking it up a little bit and taking it to a higher level.